Okay, going back to the distribution factor, I forgot to mention the use of this concept, no? What is the use of the distribution factor? So, let's say you have still here the frame, no? Having 3 members meeting at joint A. Okay, so assuming a moment is induced at A, M equal to 60 kilonewton meter. Okay, so how much moment will member AD, AB, AC will resist to counteract the moment that is applied at A, which is 60 kilonewton meter. So, mao nang anhin na nimo gamiton ang imong distribution factor. So, we have determined before the distribution factor for AD, AB, and AC. Okay? So, for AD, we have determined its distribution factor equal to 1/6, for AB, 1/3, and for AC, 1/2. Okay? So, since a moment is induced at A equal to 60 kilonewton meter, the moment that will be resisted by member AD is equal to 1/6 of 60. So, mao na gamit sa distribution factor. So, MAD will now be equal to 1/6 of 60, and that is equal to 10 kilonewton meter. And for AB, 1/3 of 60, 20 kilonewton meters, and MAC is 1/2 of 60, so equivalent to 30. So this one here is the free body diagram of joint A. Okay, so naa kay moment nga gi-apply nga counterclockwise moment equivalent to 60 kilonewton meter. So, to make this joint equilibrium, so ang tulo ka members nga nag-meet sa joint A will resist the moment applied at A, no? So, pila may iyang i-resist. So, maotong ang MAD is pila man ni 10 kilonewton meter. Ang MAB is 20 and MAC is 30. Kung isum up po ninyo silang tanan, will give you 60 kilonewton meter. Kaya ingon man lagi nga, the summation of the moments at the joint should equal to 0. So, nakay 60 nga counterclockwise. So, ang imong mga moment nga gi-resist sa tulo ka members will be clockwise para equilibrium. So, ang sum up nila is 60 clockwise. Ang imong moment nga gi-apply is counterclockwise nga 60. So, kung i-add nimo sila, it will be equal to 0. Okay.